Hi, everybody. So this is the last problem set before our exam on Thursday. Sorry it took me so long to get this up, but let's just get into it. So the first question starts out with the fact that your group determined the launch velocity of the marble launch should be about 6 meters per second. And if we launch it at 70 degrees above the table and lands 1.25 meter below where it started, how far away from the base of the table does it land? So this is almost if we take the marble launcher and put it on one of the lab benches and then put the cup on the floor. How far out do we put the cup? So to start this out, let's go ahead and do a little bit of trig. So we're going to start. In fact, let's do something a little neater than this. Let's start with that being our launch vector, which is going to be 6 meters per second, and we have to break that into x and y components. Try and clean this up a little bit. Yeah, close enough. All right. And the angle that we have is 70 degrees from the table. So this is typically where we're going to be putting the angle. So a lot of you have asked me, how do I know where to put the angle? Typically, this is it. You know, we're launching something this way, and the idea is it's going to come back down and either land at the table or below the table or above the table, but somehow or other this is sort of the general idea of the triangle that we're going to be using. So to figure out the y component, which is the vertical component, which is this side, we're going to be doing x sine of 70 and then 6 cosine of 70. And if you have issues with that, come talk to me because we have to work on your trig. So 6 sine 70 should give us 5.63. And 6 cosine 70 should be 2.05. So this is 2.05, 2.050, negative 9.8 because we're dealing with a projectile, and 5.63. Now the other thing is we need a displacement is between the edge of the table and where this thing lands is negative 1.25 meters. So negative 1.25. That's something good there. Now what we normally do is figure out the time, but we don't have the final velocity because we can't make the assumption that it comes back down to the table at negative 5.63 meters per second. This thing goes up and comes down further than the table, which means it's actually going to be going faster in the y dimension than 5.63 meters per second because it gets to fall further. So what we have to do is figure out the final velocity before we can figure out the time. So the way we're going to do that, and I'm just going to scoot down here, we're going to do VF squared equals VI squared plus 2AD because I have a VI, I have an acceleration, and I have a displacement, and I'm looking for the final velocity. So we have these three things, and we can use them. So let's do that. 5.63 squared plus 2 times negative 9.8 times negative 1.25. We should get positive for VF squared equals 56.1969, and then we'll take the square root of that, and that will be a velocity final of plus or minus 7.49 meters per second. Now the idea is it's landing below the table, which means its final velocity is going down. So we're going to ignore the positive 7.49. We're going to look at the negative 7.49. So let's plug that back in here. Minus, I'm going to round it to 7.5 meters per second. And if you did 49, that's fine. But 7.5 meters per second. And now that I've got this, I can figure out the time because I have a VI, a VF, and an A. So now I can do VF equals VI plus AT. So negative 7.5 equals VI 5.63 plus negative 9.8 times time, which I can figure out now. I'm going to add negative 5.63 to both sides, so minus 7.5 plus negative 5.63. That's going to give me negative 13.13 equals 9.8 t. Divide both sides by negative 9.8. And we should get a time of 1.33 seconds. So 1.33 seconds. And now for the displacement in the x, I can do v equals d over t, because now I'm dealing with the x stuff. D over t, so 2.05 equals d over 1.33. So times 2.05, we're going to be dealing with about 2.74 meters away, give or take, given rounding. Okay, so I hope that helped. Let's look at number 2. Somebody hijacks my potato cannon. Remember, it shoots projectiles at 45 meters per second. So again, we're going to make this 45 meters per second. They bring it to Cunningham Park, and they shoot it 55 degrees over the horizontal. So now I need to figure out the x and the y again. The potato lands on somebody's roof on the way down. I added this in. That is 15 meters above where it was fired. How far away is the house? So now we're shooting it up 15 meters, but it's going on the way down. So the final velocity is actually going to be negative, and the displacement in the y is going to be positive. So just sort of keep that in mind. So now I can do, for my x, it's going to be 45 cosine 55, and that's going to be 25.8, 25.8, 25.8. And for the y, it's going to be 45 sine 55. That's going to be 36.86. And I want to put negative 36.86 here, but I can't because, again, we're landing 15 meters above where we started it. But we do know it's going down, so I am going to leave that negative there. Okay? So now I'm going to do what I've done in the past. I'm going to use VI, A, and D to figure out VF. And the equation to do that's going to be VF squared equals VI squared plus 2AD. VF squared equals 36.86 squared plus 2 times negative 9.8 times 15. 36.86 squared plus 2 times negative 9.8 times 15. So we should end up with VF squared equals 1064.65, but whatever, we're going to square root that because we don't want VF squared, we want VF. Square root of that answer is VF equals plus or minus 32.62. So interestingly, it's going up 36.86 and it's coming down 32.62, which actually should make sense because it doesn't get to fall as long as it got to go up. So you'd expect that it would actually be going slower here than if we let it come back down here. So plus or minus 32, we're going to take the minus 32.62. And now I can start looking at my time. So I got a VI and a VF and an A. I can figure out T. VF equals VI plus AT. So negative 32.62 equals 36.86 plus negative 9.8 T. So negative 32.62 minus 36.86 equals negative 69.48 equals negative 9.8 t. Divide both sides by negative 9.8, and we should end up with 7.09 seconds. So time is 7.09 seconds. That can go here, 7.09 seconds. And now I can do V equals D over T for the X stuff. So 25.8 equals D over 7.09. So times 25.8. That should give me 182.9, call it 183 meters away. Okay, so I hope that made sense. Next up, soccer player. This is finally an easy launch problem. We're dealing with 20 meters per second, 25 degrees above the horizontal. But now the idea is a soccer ball is starting on the ground, and where does it land? Back on the ground. So we can use whatever we find for our y velocities, we can use the plus here and then make it the negative here because we know it's going up with some velocity and then it's coming back down with that same velocity. So again, for my x and for my y, we're going to be doing 20 cosine 25 and 20 sine 25. 20 sine 25, that's going to be 8.45 for the VI and the Y. And 20 cosine 25, it's going to be 18.12. So in the X, 18.12. 18.12, 0, negative 9.8, and negative 8.45. Again, because this is landing back on the ground. So now that I got this, I can figure out time pretty easily. VF equals VI plus AT. We basically, because of this, we get to skip the VF squared equals VI squared plus 2AD thing. So negative 8.45 equals 8.45 plus negative 9.8 t. And I'm going to go ahead and just solve for t because I know we know how to do the algebra here. 9.8. That's going to give us 1.72 seconds. So that's my time, and now I can use 1.72 in B equals d over t to find the x displacement. E equals d over t. So 18.72 equals d over 1.72. We should end up with about d equaling 32.8 meters away. Hope that makes sense. Number 4, projectile is launched from the ground and with a velocity of 70 meters per second, and it hits a target that's 130 meters high. Projectile hits on the way down. How far is the x dimension of the target? So this is very similar to the Cunningham Park problem that we just had. Oops. So let's go ahead. Turn back on light. Whatever. I love when the light turns off. So we're going to go again with 70 meters per second at an angle of 55 degrees above the horizontal. X and Y. And the rub here again is positive 130, so it hits 130 meters high. Final velocity is going to be negative. That's 0. That's negative 9.8. This is going to be 70 cosine 55. This is going to be 70 sine 55. So 70 sine 55. That's going to be 57.3. That's going to be 40.1. So 40.1, 40.1. This is going to be 57.3, but because we have a displacement, it can't come back down at negative 57.3. It's going to come down at something else. So again, we have to figure out the final velocity. And we'll do that using the equation VF squared equals VI squared plus 2AD. So VF squared equals 57.3 squared plus 2 times negative 9.8 times 130. We'll just plug that into the calculator. 57.3 squared plus 2 times negative 9.8 times positive 130. It's going to give us a VF squared of 735.3. And then we don't want VF squared, we want VF, so we'll take the square root of both of those. Square root, and we should end up with VF equaling 27.11 meters per second, plus or minus. Remember, this thing is coming on the way down, so we're going to have the minus 27.11 meters per second for the final velocity. Now that we got this, we can do VF equals VI plus AT to find the time, plus AT. So negative 27.11 equals 57.3 plus negative 9.8 t. We're going to subtract 57.3 from both sides. Minus 57.3. That's going to give us negative 84.41 divided by negative 9.8. We will end up with a time of 8.613 seconds. So I'm just going to round that to 8.6 seconds. And now again, I can do V equals D over T, all in the X dimension. So 40.1 equals D over 8.6. Multiply both sides by 40.1, and we should end up with a displacement of 345.4 meters. So hope that made sense. Next one, this actually is very simple. Boat is heading due north on a river flowing east at 5 meters per second. So the boat is heading due north, and the river is carrying it east at 5 meters per second. Wouldn't it be nice if we knew what the boat was set to? The boat is set to 10 meters per second. Well, that helps. What's the actual velocity? Which means we need to figure out the angle also. But let's figure out the speed, which is going to be Pythagorean theorem, 10 squared plus 5 squared equals 125. The square root of 125 is an error. That's not good. Square root of 125 is 11.18, so 11.18 meters per second. And then for the angle, we're going to use the opposite and the adjacent side. And when you're figuring out the angle, you're going to do inverse tan of the opposite over the adjacent, which is 5 over 10, so inverse tan. Second tan, 5 divided by 10. That should be 26.56 degrees. So 11.18 meters per second at 26.56 degrees, technically east of north. Because we're going east after we go north. Okie dokie. Hope that made sense. That really wasn't supposed to be too hard. So there's that. And then finally, a tough cliff problem. Plane is flying at an altitude of 5,000 meters. It releases a package that lands 1,800 meters away. So all I give you is displacements. So this is going to be interesting, isn't it? So here's my plane, bad plane. It's flying 5,000 meters high, and this package lands 1,800 meters away from where it started. So we know two things. This is 1,800 and this is 5,000. Although not just any 5,000, the package goes down, so it's negative 5,000. We know the initial velocity in the y, we know the accelerations, and that's really it. And what do we need to figure out is the velocity in the x dimension. So somehow we're going to figure out time, because that's what we always need. Again, I think the easiest way to do it's going to be to figure out final velocity and then figure out time in the y dimension. Although you could do d equals VIT plus 1/2 AT squared, because VI is 0. This is all going to become 0, so actually let's do it. So d is going to be negative 5,000 equals VI, which is 0 times t, which is still 0, plus 1/2 of negative 9.8 is negative 4.9 t squared. So let's do negative 5,000 divided by negative 4.9. We will get 1,020 equals t squared, but I don't want t squared, I want t. So we'll take the square root of 1,020 We should get 31.94 seconds. So now we can use v in the x equals d in the x over t in the x. So that is v in the x we don't know, but d is 1800 over 31.94. 1800 divided by 31.94, and we should end up with 56 meters per second, which is about 100 miles an hour. Kind of cool. The other way to do this is to do VF squared equals VI squared plus 2AD and figure out the VF and then figure out the time, but I believe, actually, you should get the same time there for that question, or for that part of the problem. Then again, 56 meters per second after that. So I hope these 6 problems made sense, and if you need anything else, I'll be checking email tonight. So if you have questions, just feel free to shoot me an email, and I'll do my best to answer them. Okie dokie. Hope this made sense, and good luck studying.